Hey everybody, in this video we're going to continue studying section 2.1 functions, and we're going to talk about domain and range. So I have this function here, so let me call it f of x. And we don't know the rule, but we have the graph, and so with the graph we can find the domain and the range. So remember, the domain is all the x values for which a function is defined. So here, now the arrows, this indicate that the function is going on forever. So this is going to continue going to infinity, and which means it continues on the x-axis as well, going to infinity. The arrow here on the right means the same thing. So this continues on forever to infinity on the y, but it's also moving along on the x. So it's going to go to infinity on both. So we want to look at, is there anywhere that makes the function undefined on the x-axis? And so as long as I have a value, it's okay. Now notice here, right around at 1, and that is a solid circle. So even though that one is open, the fact that x equals 1 does have a y value here, and it only has one input, right? Had that one been solid as well, at y equals 1, this would not be a function, because you need to have one input can only have one output to be a function. So the domain here is going to be all real numbers, minus infinity to infinity. It appears that there's no value at x equals 1, but when x equals 1, the y value is 0. So there is a value there, and there is only one value. So this has a value everywhere. So the range, now remember, the range is the y values for which a function is defined. So notice that the graph does not dip into the negative y-axis. So I have, this is my x-axis, this is my positive y-axis, this is the negative y-axis, and that's the negative x-axis. So there's no portion of the graph underneath the x-axis, so going into the negative y values. So the range, the first value that we see is 0. And so, n is included because we have the solid circle there. So my lowest y value is 0, and what's the highest? So it appears here that 1 might be missing, but then when you follow it over here, you see that it's solid there. So 1 is included in the range because this portion of the graph picks it up. So it goes all the way, the arrow says it goes to infinity. So the range of this function will be from 0 to infinity. Now let's look at when you have the rule for a function. So given the function, the rule for a function, we're going to try to find the domain and the range. So let f of x be, say, the square root of x plus 4. So how do you find the domain of something like this? Well, I have a square root. So what do you know about square roots? Or even radicals in general? We can't take the square root of a negative number. So notice that if I start saying, trying to find values, right? If I do f of 0, what's f of 0? Plug it in. F of 0 is telling me to find the y value when x is 0. When x is 0. So when x is 0, y is going to be f of 0, which is the square root of 0 plus 4, which is the square root of 4, which is 2. So f of 0 is 2. So that will be, our coordinate point will be x is 0, y is 2. So what if I want to find, say, f of negative 3? Can I do that? We said we can't take the square root of a negative number. So what's f of negative 3? So f of negative 3 is asking us to find y when x is negative 3. So let's plug it in. So f of negative 3 will be the square root of negative 3 plus 4. But negative 3 plus 4 is a positive number. I get the square root of 1, and the square root of 1 is 1. So we're okay there. So saying we can't take the square root of a negative number doesn't mean that x can't be negative. right? And notice that even with f of -4, f of -4 will be the square root of -4 plus 4, and that gives us 0. The square root of 0 is 0, so this will be the point -4 comma 0. This one is the point -3 comma 1, and so on. So what about f of -5? What does this one become? Sorry, I switched screens for a bit there. So f of -5 will be the square root of -5 plus 4. And now we have a problem because -5 plus 4 is -1, and we can't do that. This is I, which is not a real number. So I found my first thing that's not in the domain. I can't take the square root of -1. And so anything less than that is going to be a problem. So one of the things we can say is for f of x equals to the square root of x plus 4, since we can't take the square root of a negative number, that means we want the inside of the square root. We want x plus 4 to be greater than or equal to 0. Since the square root of 0 is 0, we want the equals there. And then solve this inequality. So subtract 4 from both sides, we get x is greater or equal to -4. And when you put in a number line, I put -4. I have the equals, so fill it in and then shade for x greater than. So this gives me our domain. So the domain would be bracket -4 because we're including it all the way to infinity. Now for the range we may have to look at the graph of this function, or we can kind of do it by analyzing it. For the range is the y values. So what is the smallest y value we can get? And we can you can already look at the values that we got. Notice that when we did f of 0, we got 2, f of -3, we got 1, f of -4, the smallest x value we can put in, we got 0. So notice that for the smallest x value we can put in, we got 0, and then they increase 1, 2, and they're going to keep increasing. So our range is going to be from 0 to infinity. Now, if you happen to remember from your intermediate algebra class what the graph of the square root looks like, based on this domain, since it starts at -4, this is not drawn to scale, the square root is a sideways parabola graph, so this one's going to start at -4, and it's going to go that way. So you can see here, based on the graph, that the range will be from 0 to infinity. But we will learn other ways of finding the range later on. Right now, I want to kind of focus on the domain. The range, you're only going to be asked for the range if you're given the graph. So let's try other examples of domain. So say I want to find the domain of, say for f of x equal to 1 over x squared minus 9. We're going to do that one, and we're going to do g of x equals the square root of x squared minus 9. So how do we find the domain? And as we talked about earlier, we don't want, when you have denominators, you can't have 0. So in this case, we have a denominator, and the denominator cannot be 0. So that means we're going to exclude any values that make the denominator 0. So exclude any values that make x squared minus 9 equal to 0. So let's solve that equation for x. And this we can do it by factoring. This is a difference of perfect squares. So this factors into x minus 3x plus 3. So either x is equal to 3 or x is equal to negative 3. So that means that x, right, it says we're going to exclude those values. So the domain, and again, in words, the domain will be all real numbers except x equals negative 3 or x equals 3. So that will be written in words. In interval notation, to get to interval notation, I'm a visual person, so I always draw myself a number line. So I'm going to put negative 3 and 3. And what it says is everything except those numbers. So if I put circles on those, I don't want to include that. But then it says all real numbers, so I'm going to shade everything but those numbers. So all real numbers except 3 and minus 3. So the domain in interval notation will be negative infinity to minus 3, not included, union, the middle, negative 3 to 3, union, and then the right, 3 to infinity. And you can write it in set builder notation as well, as we did in the first video. Now for the second one, notice that the equation or the expression appears almost the same. I'm using the same quantity, x squared minus 9, but now we have a radical. So in this case, for the domain, we can't take the square root of a negative number. So that means that we want x squared minus 9 to be positive. So in math, how do you say that? We want that to be positive. So that means we need to solve x squared minus 9 greater than or equal to 0. And so we use here our practice from chapter 1, how do you solve nonlinear inequalities? And remember, we can go back to the steps. To solve nonlinear inequalities, you need to have 0 on one side, which we do, factor completely, get the zeros of your factors, put them on a number line, and then do test points to figure out the products, and then write it in interval notation. So this I already have 0 on one side, so now we're going to factor completely, which we already did in this other example. So this factors into x minus 3x plus 3. The zeros are x equals 3 and negative 3, so I'm going to put them on a number line. And we want the product to be positive, so we're going to use test points. So this is different than the equation here. Here we were solving x squared minus 9 equals 0. So I'm just solving for the values of x. Here I want the quantity x squared minus 9 to be greater than or equal to 0, so it's a little more involved. It's not an equation. We have to do the test point method. And now notice that I can include them. So when I put circles on negative 3 and 3, I can fill those in because they are included. And now I'm broken it up into 3 sections, 3 regions. So we're going to test the left region, the middle, and the right. So let x equals, say, negative 4. Negative 4 minus 3 is minus 7. And negative 4 plus 3 is minus 1. This product is positive. Pick something between negative 3 and 3. Let x be 0. And I get 0 minus 3 is negative 3. And 0 plus 3 is positive 3. Negative times a positive is negative. And something on the right, pick something bigger than 3. I don't know, 10. But this is something random. So 10 minus 3 is 7. And 10 plus 3 is 13. Both of them are positive, so the product is positive. And we did say we wanted things that were positive. Up here we said we want x squared minus 9 to be positive. So we're going to shade where we have the product is positive. And so the domain for this function then in interval notation would be minus infinity to negative 3 included, so bracket union 3 to infinity. Right? So notice how different these two problems are, mainly because one was just a denominator, so I was just solving an equation. In this one, I'm solving an inequality. Now, what would change for this problem what if my function was g of x equals 1 over the square root of x squared minus 9? What changes in finding your domain? We still can't take the square root of a negative number, so we still want x squared minus 9 to be positive. But notice that now it's in the denominator. And now we also want x squared minus 9 to not be 0. So the only thing that changes is that then, so we can say we want x squared minus 9 to be strictly greater than 0. So the solution of the domain for this function g of x will be the same as this, except that instead of brackets at -3 and 3, you're going to have parentheses because now it's not included. Anytime you have denominators, exclude the values that make the denominator 0. Anytime you have radicals, you want the inside of the radical to be positive, so greater than or equal to 0. And then depending whether your radical is in the denominator or not.